Hello, everyone. It's great to be here today. Share a little bit about what we're doing in my lab at UCSF and some bigger visions about how to keep our brain healthy, especially as we get older. I want to start with pointing out that us humans have always been consumed with high-level performance. And in the world of physical fitness, the pursuit of optimal performance has been an escalating global obsession for many decades now. So across the domains of strength, endurance, power, speed, balance, agility, flexibility, specialized programs, practitioners, and equipment exist for all of these to optimize them. And this is with pretty broad goals, from wellness to competition to healthcare. But what about the brain? What have we done to optimize that core function that most defines us as human, our cognition, memory, attention, perception, decision-making, emotional regulation? I would say, unfortunately, in that regard, we're not doing quite so well. So if you think about optimizing cognition in people that are healthy, I would say the best route that we have for that now is what we think of as education. But traditional education really focuses on transferring information content, but not strengthening those underlying information processing systems, cognition, that really defines how our brains operate. And from the point of view of people that have impaired cognition, I would say that our mental health care system has really focused on this one single approach, the pharmaceutical. Now, I don't think that there's anything inherently wrong about using a molecule to improve how our brain functions. But the reality is we've been trying for over 50 years with this approach, and we don't have one real true success story. A lot of that is because these medications, while targeted to neurotransmitter systems, are not really acting at the neural network level, the real underlying aspect of how our brain works. And therefore, we wind up with a lot of side effects on top of our effects. And so this is a definite challenge of our current system. When we think about the older brain, we also know that there's lots of challenges in cognition. So does anyone recognize what's going on over here? Maybe you've experienced this once and twice. So my research has focused very much on this phenomena, sometimes known as the senior moment, right? The arriving at the refrigerator only to have no idea what you're doing there. You can rest assured that this is not just a senior moment. There's a moment that everyone experiences. But we do know that this increases as we get older. And a lot of our work has been figuring out what is going on here, what's causing this, and how can we use modern technology to increase how our brains function throughout our lives, including when we're older, so that we have a better ability to interact with our complicated environment, even in very simple situations like this. And so we call this type of deficit not really a memory problem, right? We know that you all have the ability to hold a single item in mind for 7 seconds. It's not really a memory problem. We think it falls more in the domain of something that we think of as cognitive control. Now, cognitive control is the set of mental abilities that allow us to interact with our world based on our goals. And we put those in 3 different categories that are overlapping but somewhat distinct. One of them is attention. So your ability to direct your resources, your focus, where you feel it's relevant, and to sustain it there. Another is what we call working memory. So when information is no longer around, but you want to hold it in mind in order to guide your behavior, you have to be able to do that. You can't just live in the moment. You have to actually move from moment to moment and hold things in mind. And then the last is what we call goal management, when you actually have more than one thing that you want to do at a time. How do you either switch between them, or how do you multitask to try to engage in both at the same time? We found in our lab, using tools like functional MRI, electroencephalography, EEG recordings, and brain stimulation, that these skills, which rely on networks in your brain, very high-level functioning of a brain to do these things, decline as we get older. Not everyone, but in general, these are at their height in early 20s and decline throughout life. It's not something that just happens when you're older, whatever that means, but it happens throughout life, throughout the aging process. And so we're very interested in how we might enhance our cognition so that the declining of these abilities is not so impairing to us. And when we first entered this world of enhancement, we looked across the entire playing field of all the possible ways that you might improve your brain function. I'm not going to go into all this list. This is part of a longer lecture. But I can tell you that there's one particular way that really caught our attention that might be surprising to you, not surprising to you if you know some of my work, and that's video games. And we're very interested in video games for several different reasons. First of all, as you're probably aware, the world of video games is changing dramatically. There was a time that video games were largely played by young boys. Young boys still play plenty of video games. But we know that the average age of gamers are increasing, rapidly approaching 40 years old. We know that it's pretty much 50-50 male-females now, and it's thoroughly global around the world. These games are interactive, they're immersive, they're engaging, they're fun. There is no doubt that they are a powerful way to change behavior, either in a good way or a bad way, but they are behavioral influencers. And so our idea is, can we harness the power of the video game to change the brain? How does the brain change in the first place? That's through this phenomenon that I'm sure you've heard of called brain plasticity. What brain plasticity means is that our brain can change itself at every level, from its structure to its function to its chemistry, all in response to how we interact with the environment around us. And so if we create a very tailored environment in the game, we could challenge the brain and improve it. That's the idea. This is a little bit of what it looks like. Here's your brain, here's the game. When you're playing, something in your brain triggers you to do something in the game. Now, maybe the game is pushing on your memory or your attention or your multitasking, so you respond, you have a behavior. The game detects this, or at least the games we build, detect this in real time. They know if you're right, if you're wrong, if you're fast, if you're slow, and then based on that information, they feed back a different environment. That environment might be that the game gets a little harder if you get a little better, or if you're getting tired, it may back off a little bit, or it might just give you rewards or feedback. We call this a closed loop. This is a very, very powerful way to change any system. This is not how our current pharmaceutical system works, right? A closed loop means that you intervene, you record the impact, you change based on that, and you reapply. And this is how you could change anything, a physical or a biological system. Now we take a medication, you go home, you subjectively evaluate if it's making you better or worse. You go back maybe a month later, maybe months later, you account that data, and then you get a decision about going up or down a little bit. Not a great way of changing something, especially something as complicated as the brain. So that's why we feel that this video game mechanics of adaptivity and feedback could be quite powerful. And so I challenged myself and my laboratory almost 8 years ago to see if we could create a customized game to improve cognitive control abilities, those very abilities that cause problems when you arrive at the refrigerator, with a video game in older adults. And to do this, I reached out to friends of mine that worked in the video game world, actually here in San Francisco at LucasArts, George Lucas's video game company, which is unfortunately not with us any longer. But we built this game called Neuroracer. And in Neuroracer, you play it by multitasking, which is a real challenge for anyone, nevertheless us as we get older. And we know that very well from our researcher. And so what it looks like is you're driving a car on the road, trying to keep it with a joystick centered, not too fast, not too slow. And then as rapidly and accurately as possible, you're pressing the button for target signs. Green circles, not red circles, not green pentagons like this, which is very hard not to press for. And so what we're doing here is we're pushing on your ability to multitask with the hope that if you get better at this, that we'll see benefits in other aspects of cognitive control. That was our hypothesis. So it took us a year to build this game. And then it took us 3 years to do the research. And I'm just going to give you a quick snapshot of some of the data. What you're looking at here is how well people multitask on the game, on those two tasks. So 0% where the red line is means that you multitask perfectly. It means that you do that sign task as rapidly and accurately when you do it alone compared to when you're driving that car at the same time. Now, 20-year-olds believe completely that they will be perfect at this task, right? They are multitasking masters to their own minds, right? And so we ask that question, how good are they at this? And we see that they're not so good. They drop 27%, even a healthy 20-year-old, which is sort of the peak of the pyramid in terms of cognitive control, when they try to do these tasks at the same time. Now, we already know that 80-year-olds are going to have trouble with this because we've tested that before. What we didn't know is when does this occur? When does this really start creeping up on you, the challenge in multitasking? What we find is this. It's really something that occurs throughout our lives, right? Being older is basically not being 23 years old anymore, right? So it's a reconceptualization of what we think about as aging, right? It's a process. It's not an event. And so this is the first thing we found. The next thing is that we wanted to use the video game as a way of determining how the brain was operating, not just performance. And so we recorded brain activity in our lab with one of these caps here, a 64-channel EEG cap, to look at the electrical activity. And we were interested in this measure right here. This is known as midline frontal theta. So putting the name aside, essentially what it is a measurement that shows how much the front part of your brain is activating right at the most challenging part of the game, when you're driving along and right when that sign comes up. And if you look at younger adults, you could see this yellow over here. So the nose is pointing up, the ears are to the side. This is how we represent the EEG data. And this yellow means there's a burst of activity. So yellow is like three-quarters of the way up this spectrum. Red is the most, blue is the least. If we look at our 70-year-olds, what we see is this. So there's a burst of activity, but it's only sort of at the level of green. So they're not engaging our participants. They're not engaging the front part of the brain as well as the younger participants, which we already had an idea that was going to happen because that's what you need to engage in order to do the task. So then we brought another group of older adults back. So older adults in this study was defined as 60 to 80 with no signs of any cognitive impairment or dementia. So very healthy, high-performing older adults. That's the group that we're studying here. So what they do is they play the game at home for 1 hour a day, 3 days a week, for 4 weeks. So 12 hours of playing at home on a laptop is what we did. And then we brought them back into the lab. And what we found is that their ability to multitask on the game and their brain looks like this. So dramatically improved, even exceeding the level of our 20-year-olds on a single visit. And you could see how different the brain activity is, right? This red is the very peak of the scale. We didn't even achieve that in a younger adult. So we showed a really remarkable ability to improve on gameplay along with brain changes. And then we also found that this skill really didn't even decline 6 months later without playing at all. But probably what's most important is that other cognitive control skills like working memory and sustained attention, also known as attention span or vigilance, improved as well, which is interesting because we didn't directly train that in the game. But we believe that all those cognitive control skills, working memory, attention, and goal management, multitasking, are related to each other. So that's the idea. You put pressure on one, hold pressure, keep pushing, and then other parts of the brain that are related to it also improve, and you get what we think of as transfer of benefits. That's what we're trying for. We also learned a little bit about the neural mechanism because of the brain recording. So what we find is that not everyone shows this pattern. But those that show this pattern the most, where their brain has changed over the course of the month, those people show the most improvements in that other task, that attention span task. They also show the most sustained benefits in multitasking 6 months later. So that's how we start to piece together how we design a game and use neural recordings to understand the mechanism. So now that when we move forward, we know how to evolve from there and build something even better. And so this was published in, this is one of the best journals in our field. It was quite a big moment for us after 5 years after starting this study in Nature. And it really is a message about what does it mean to be a game changer. And I think what is a game changer, if there is one and only time will tell, is that we start doing studies like this, even though they take a long time, where we build using a team approach, where we have experts in the field that know how to build these games at a very high level. We work with them, and we direct the game towards deficits in a population. It doesn't have to be older adults. It could be any population. And then we do very careful placebo-controlled studies with neural measures to understand what's going on. We treat it at least, if not higher, than we treat the research that we do on drugs. That is the goal, and that's what we're trying to do. So what's happened since then? A couple of things. This is the type of experiments we're doing in our lab now. I'm not going to spend a lot of time on this. It definitely takes a while to break it down, but I just wanted to show you where we're going. What we're doing now is we're recording brain activity in real time. And in two types of experiments, one, we're feeding the activity into the video game. So essentially, the video game doesn't just know if you're fast or accurate, it knows how your brain's responding. And we think with that tool, we could refine brain processes that are deficient at a higher level than anyone has ever seen. The other thing we're doing is we're using brain signals to guide a stimulator, so that we could stimulate your brain electrically and hopefully increase its processing. We have some data to show that's true. So maybe we wouldn't do that in healthy people, but maybe if you had a traumatic brain injury and had the need for a little extra boost, so to speak, while you're training, this type of tool might be available. And so you could see here, we're looking at an approach that is much more targeted and personalized and closed loop, multiple closed loops that we think is going to be the future vision of what we think of when we think of medicine for your brain. And not just healthy older adults that have problems with cognitive control, but a larger segment of the population. Another thing that's going on now is that I helped move the technology from UCSF into a new startup that I helped form. Matter of fact, a lot of the folks from LucasArts are now full-time here. And they're trying to create a game that's even of a higher level. And this is a little peek of it. So there's better music and art and story, all of which you need for people to engage if they're going to do it for a long period of time, especially if you want the games to also be played by kids who are used to a pretty high bar when it comes to games. Interestingly enough, the company has decided not to make this game consumer available. So you can't just download it on the iTunes store. What is happening, which is very unique, is that the game is going through careful clinical testing around the US right now for multiple conditions to see if it can be FDA approved as a true diagnostic and therapeutic, the type of thing that a physician might prescribe on a pad alongside or instead of a drug. So one of the first big targets are kids that have ADHD, which we know they have a lot of those same cognitive control deficits that we already talked about. So I don't know the answer to this. These studies are going on now. But I think it's a very exciting potential to think about essentially a new class of medicine, like a digital medicine, and one that's a lot more fun than taking pills. So we shall see. The jury's still out, but we'll know within a year. In the meanwhile, at my lab at UCSF, we built a new lab called the Neuroscape lab to try to build new tools that are even way higher level than what I've already shown you. And so we have 4 games. This is what the UCSF neuroscience building looks like. It's only a couple years old. This is what our new lab looks like, not your typical neuroscience lab, but it does function as one. And so we have this really amazing control room, looks like a NASA control room there. And then we have our experimental room, which is a lot like a very high-level game studio where people could do experiments in virtual reality. They could do motion capture. So we could do all very high-level type of studies using technology that really largely exists in the world of entertainment and media and communications, you know, and all these amazing tech companies around us. We don't want it to live in those domains alone. We want to take it and put it in the lab and figure out, can these be tools to improve the quality of our lives, right? Can they help us function better? That's what we're trying to do. These are 4 new games. We don't have a lot of time. I'm just giving you a quick peek at some of them. We actually have others, but these are the 4 that are the furthest along. We have a game called MetaTrain, Rhythmicity, Virtual Attention Body Brain Trainer. Just to give you a little sneak peek at what these look like, MetaTrain is a meditation-inspired video game that uses an iPad to help you focus and resist being internally distracted. Rhythmicity is a game we're working with many musicians like Mickey Hart, who's the percussionist from the Grateful Dead, to figure out, can we improve your brain's functions by making you more rhythmic? So that's a study that we're interested in beginning. We have a virtual reality game. This is a headset there's going to be many of these by the end of the year. So there are at least 5 companies working on, maybe more now, working on these headsets that when you put on, you're just in this world. It looks just like this world. And so way beyond what we get with 2D screens, can we take advantage of that to help us pay attention more broadly? That's what we're doing here. And then we have a game called Body Brain Trainer, which is a physical fitness game that's integrated with cognitive fitness. So it trains your physical body and your mind at the same time. Very exciting. No one has really ever done that in an integrated way. So as you play the game is adapting to your cognition. If you get things right, it gets harder. But we also record your heart rate. And so as you get in better shape, the game challenges you more physically. So it's a pretty exciting new study. All of these are research studies in the lab where we figure out before anyone will ever see them if they work or not. That's what's most important to us, to validate at a very high level and understand what is going on. Are we really looking at a new tool to make a meaningful and sustainable impact? That's what we want to know before it passes into the world. So all these studies are beginning. There's something I call neuro-CrossFit training. So CrossFit training is a term I borrowed from physical fitness. And that's the idea that we're likely to get even better or certainly different effects if we look at how these games interact with each other. So if you play the meditation training game before you do the physical fitness game, what does that mean? And we are really at our infancy in understanding anything about how to use these tools at a very high level. So that's where we're heading with that. Over the next 10 years, we're going to see how the tools that we're developing and validating in healthy people have an impact across all these conditions. So the first thing we do, healthy 20-year-olds, then older audiences all the way up to 80, younger down to 8 or younger is what we're talking about. And then we see what does it mean for all of these conditions? How can strengthening the brain, even if it doesn't eliminate these diseases, at least what does it mean to the symptomatology to have a stronger functioning brain to deal with these conditions? We really do not know a lot about that yet. The last thing I want to tell you on this is that we are now very interested in looking at these as educational tools. We're reaching out to schools all around the Bay Area is where we're starting and saying, what do these games do? I mean, kids are going to play games anyway, but if we could design games that are targeting cognitive abilities that we want to have enhanced, will that improve and be essentially a new form, or at least a supplement to the education that they're getting or not getting right now? Okay, so that's sort of the very high vision. That's my world. That's where I live. But some of you are asking yourselves right now this question: what do we do while we wait for the future to arrive, right? It's going to take us a while to do that work. And I'm very conservative. I don't like, and I know there's going to be questions about these things. What do we do about all the brain games now and things like this? And the reality is, I don't know. I'm going to answer that question right now. A lot of those things that are out there right now, we do not have a lot of data if they work. Not everyone does what my lab does, which is produce the highest level of research before we say, hey, this will help your memory. It's the reality. And it's not just the games out there. I mean, it's nutraceuticals. There's a lot of things out there that are not carefully validated. So I'm going to tell you a couple things that I just feel confident that are important things to do to keep our brain healthy while we figure out the more complicated technology piece to this. First and foremost, exercise. Probably the best evidence of all exists in this domain. Both aerobic exercise and weight training, resistance training. And this might mean long walks, brisk walks, or more, depending on what you're capable of given other aspects of your health. But we now know that physical exercise is a powerful source of brain health for lots of reasons. That's why we're combining it with cognitive training to see if we get a boost effect. But in either case, this is my strongest recommendation. There is evidence, not as high as for physical fitness, that nutrition, that what we eat is good for our brain, which makes sense, right? Our brains are part of our bodies. Probably this type of diet, known as the Mediterranean diet, right? Legumes and nuts and fruits and fish and olive oil, and everyone likes to see red wine on the list, especially Northern Californians, seems to have evidence that this is good and healthy for our brain, especially as we get older. So that's another thing I think is more likely than not going to be good for us. This is another one, stepping out of our comfort zones. Our brains respond to challenge. It does not respond to comfort. It's not how the brain works. It never worked that way. Just when you were younger, you were just never comfortable. Now, as you move through life, you figure out how to be more comfortable. And I don't necessarily mean something as crazy as that, but even socializing, travel, challenging yourself is good. Now, stress is a complicated one, right? Stress in high levels is certainly detrimental to your brain and other aspects of your life. But some stress is good. Stress causes us to respond and to elevate ourselves. And so, you know, it's always a tricky line with stress, but I think challenging, being uncomfortable sometimes is good for your brain and good for your health. And with that, I want to thank you for your attention. I know some of you are going to ask about signing up, and therefore on this next slide is going to be our email lab for participation. You could also get it by going to Gazzaley lab at ucsf.edu, or gazlab.com is a quick way of getting there. But basically it's info@gazzaleylab.ucsf.edu. And so send us an email. You might not be eligible for every study, so don't take it personally. It's certainly not a personal decision. Some studies have different qualifications, and we do a lot of studies. Sooner or later, we're likely going to reach out to you. All right, so we have time for some questions.
Do you still screen for MCI?
We do. Traditionally my lab, and I know some of you, who knows our lab already, who's interacted with us? Okay, a lot of people up front. Traditionally, my lab studies healthy aging. That's always been a fascination of mine for over 20 years now. What happens to our brains as we get older without Alzheimer's disease? Not that Alzheimer's disease is not fascinating and important and critical to learn, but I was really interested in what happens to our brains under the best of conditions. So that's my specialty and has been for a long time. We are also interested in my lab in that earliest phase of Alzheimer's, what we call MCI, or mild cognitive impairment. Sometimes we do studies on that population. More often than not, we do studies on people who are very healthy and older to see what's happening in the brain, even under the best of circumstances. But just these are our own lab, sort of focuses. Oh.
Sir, I was wondering if, since you set a high bar for your research and any conclusions you may suggest, in terms of things like meditation and this latest craze, mindfulness, do they, in terms of your technology, are they up to snuff? I apologize if I'm not articulating this question accurately, but I'm kind of confused because some people say there's awareness, there's attention, and then there's concentration. And I don't know what is actually being trained or being tested.
Okay, let's talk about mindfulness and meditation. I probably should just add that as a slide at the end, because especially in this part of the world, not every part of the world, but certainly here, that was my mistake. First of all, I'm not a meditator myself, although I'm very interested in it. And we have one of our games that's meditation-based. And I played our game, which is like meditating. It's not the entire contemplative practice that often goes along with it, but it's like one piece of it. Meditation training, essentially, and meditation itself is attention training. But it's an internal type of attention. It's different than what Neuroracer is. It's like almost the exact opposite, such that they might be very similar to each other. So instead of focusing on something outside very carefully, you're focusing on something inside, right? Often, and there's many different forms of meditation, so I'm not trying to give a global view of this entire, multi-thousand-year-old practice, but concentrative meditation requires very direct and sustained attention on something, usually like your breath is the most common. It doesn't have to be. It could be a phrase or a visual image. And then when you notice your mind wander from that, you monitor it, you're aware of it, and you just pull it back and focus again. So essentially what you're doing is sustained attention on something that's pretty subtle, like your breath, and resisting distraction. So it, in my mind, is cognitive control training, and that's why we brought it into our package. Into our project. Now, there is data out there that meditation and mindfulness practices in many different sorts can have a benefit on cognitive abilities, including those of older adults. This data exists. It should be on the list. I don't think it reaches the same exact level as exercise, because there's a lot more research on exercise and some really good studies, but it's pretty good. I certainly think that if you enjoyed it, that's the other thing, is the things I'm recommending are likely not to be harmful to you. As long as you conduct your exercise in a reasonable fashion with recommendations when appropriate. If you like this idea of meditating and find it fun and enjoyable, or feel like you're getting something out of it, by all means, continue. Same thing with video games. I mean, if you like them, even if I don't feel comfortable in saying, I'm going to prescribe this one for you right now, I would say do it. I mean, I think that for the most part, they're not very harmful, certainly if you do it in some reasonable moderation, any of these things. So that's where we stand with meditation and mindfulness. I'm really excited about our study because it's very well controlled. Very hard to do in a more natural meditation practice situation. That's the beautiful thing about using the games, is that they allow us to take what we might think of as an active ingredient of something, like rhythm training right out of music therapy, or the act of focusing on your breath right outside of the bigger practice of meditation, put it into our game engine where we use adaptivity and feedback, and now we have a way of delivering it such that it's reproducible and controllable in an experiment. This is what sort of the medical world is waiting for in a way, is that type of very rigorous methodology that's already familiar to them because that's how we test if drugs work. That's our idea, is that we could use the same exact approach to convince the world that these things shouldn't be alternative. I mean, alternative is not a great place to be, I don't think, when you're trying to create something to have really global impact. You want to be mainstream. You want it to be the type of things that people go to from the beginning. And so I hope that what we'll be able to do in my lab over the next 5 years or decade is move things that have sat on the side, maybe for too long, into the mainstream through the type of approach that we're taking.
Treating depression, how effective is it, and what is the mechanism?
No one knows how to perfectly treat depression, so I'm not going to be able to answer that question completely. You know, a lot of the medications we have, as I said earlier, change neurotransmitter systems. They offer some relief to some people for some amount of time. Some people are affected more profoundly, some are not at all. They're totally refractory to the medications. These are very complicated network properties and changes of our brain that involve every system, right? So that's why we haven't really solved any of these things, because the brain is just almost infinitely complex. Our approach, and why depression is on the board, is because depression experts tell me, and it was not my expertise is more on the Alzheimer's and aging cognition side, but I have lots of friends at UCSF that study depression, and they love our approach. They think it's incredibly interesting for depression. So why is that? Why would cognitive control and improving it help depression? Because what's a growing consensus on an aspect of depression is that a lot of it is about control. If you can improve control more generally, you can improve emotional regulation, since emotional regulation is part of what it means to have control over how you're processing the world. So that's a hypothesis that now we're testing. Even if you play a game that doesn't have emotional content, but you get better cognitive control, can you have less depression symptoms? That's the idea.
I understand that it's common for elderly people, if they've had a hip fracture or surgery, that sort of thing, that they come out of surgery with some form of brain damage and that the brain can possibly heal itself somewhat. Do you have any suggestions as to what might promote the healing after the anesthetic of surgery in the brain of the elderly?
So I would say it's the same list, right? You know, that list applies to healthy brains or unhealthy brains, right? That's like, unfortunately, or for, you know, that's the best we can do right now, is that those are the things to keep your brain healthy. It's interesting that you say that. I have been contacted by ICU specialists, one across the country, whose expertise is cognitive impairment after surgery or after ICU stays as well. And he's very interested in our game technology, get him playing the game right there in the ICU days after. Start stimulating the brain, start pushing those processes. It's interesting.
I work out every morning with a game developed by Stanford University, Luminosity.
Okay.
How do you compare to Luminosity?
Yeah, I'm not really prepared to do any like direct game-to-game comparisons now. You know, I think that the question that you need to ask yourself, no matter what you use, is what's the level of evidence that exists? And this is not just true for the games, it's true for any pills that you take and go, you know, go over the counter. I mean, some of them are pretty thin. Now, it might be fine. The side effects might be very low of playing a game or taking a lot of vitamins. In which case, if it makes you feel better, by all means, go for it. But I usually, and you know, feel, given what we do in the lab, that I'm driven by the data. At least when I give recommendations, I just can't go any other way. And so I would just ask you to look at anything that you're interested in, at the data that exists for it. I think the general concept of any game that might improve your brain is based on sort of a firm basis, and that our brains are plastic. But not everything that we do is going to be equally good, right? I mean, it's just because it's plastic, it's not Jell-O, right? I mean, it's stable too. It has to be stable. It would be dangerous if our brains were too plastic. So the idea is that you might have to do something to apply enough pressure to change it. It's like if you go to the gym, let's say, and you sort of like have 5 minutes on the treadmill, couple of arm curls, and walk out, You know that's not going to do anything. Like, we know that after years of physical fitness literature, as I started the talk with. So I think it's the same thing with the brain. You have to find a way to put enough pressure on those systems to change them.
Thank you. Do you have any games that those of us who have not heard of this ever before or played a single game like that in our lives, anything you might suggest we go and find? A generalization, since I know you can't be specific.
I knew you weren't going to let me off so easy on this. The games that have the most data out there, consumer games, are probably the games you're going to like the least. And I know that because I talk to a lot of audiences. So the first-person shooter games, the most violent of all games where you go right into this military situation, they're also not really designed for older audiences. This is true. They're really very, very rapid, and they don't have, like our games have a ramp-up period. They find where your ability is and put you in that place. These games weren't designed that way. Those games have shown that the young people that play them wind up having high cognitive control abilities. We see a lot of data that suggests that's true. So games that are very immersive and engaging, that really challenge you, that are fast, fit that category. So if you could find games like that, if you download different games and you go into your store on your iPad or on your Android or whatever device you use or on your computer, the type of games that have the most data are the games where things come at you pretty fast, you have to make decisions, those type of games in general. The slower games that maybe just challenge your memory, like crossword puzzle type games, not as much evidence. I mean, I know it seems opposite, but not as much evidence that just like looking back in your memory through distant reflections actually really help your memory. Rather games that really push you. I mean, one game that I always like, and I haven't seen data, and like I said, I don't like talking about things outside of data, but just makes a lot of sense of things like just jigsaw puzzles. Things that make you sort of use your memory to mentally rotate, it doesn't all have to be digital games. Digital games are really good for us because we get to control everything. So when you're a designer and you're building tools, digital is amazing. Also, it's accessible and it's just the future. But games like jigsaw puzzles, I think, are interesting as well.
I'm a real fan of systems approach to complex problem solving, and the multidisciplinary team sounds exactly like what you are doing. I'm wondering if in the other areas of mental health where there's an absolute lack of knowledge because we can't predict an airplane pilot going to fly his whole airplane and 149 people into the Alps, or someone coming into a Denver theater and unloading an automatic weapon. Do you see this approach, not specifically this research, but the systems approach to complex problems, and I think these are complex problems, being applied elsewhere in the neurological or psychiatric or psychological field?
Yeah, I mean, it's the art of making predictions is always a challenging one. And I don't know how broad this approach will go, but I think that this is really something, I mean, I pretty much have now dedicated my career to figuring out how to use these closed loop systems and technology in a very rich way to change all sorts of things that have been problematic for us for a long time. So I don't say that this is, holy grail, that's just like foolish, but I do think we're on to something that is powerful and will have broad applicability, maybe to things like that. I've been asked about that particular one, random extreme violence that we see. Sure. I mean, if we sat down and you work it out, when we approach a problem, we have a whiteboard and we'll spend 6 months brainstorming what would a game that's challenging this, we don't take this trivially. This is like a deep problem of 20-person teams from all different careers and backgrounds working together to come up and then I mean, it's a big, couple-year process to build any of these. So if we sat down with the whiteboard, we said, people are doing seemingly to us, random acts of extreme violence. Where does this start? How do we start pushing on whatever those systems are detecting them? And, I think it's possible to build something like this, but it's not easy.
I wanted to ask, going back to the cognitive impairment following surgery, isn't that really a function of the fact that older bodies respond differently to anesthesia than younger bodies, and the anesthesia has been standardized on younger bodies?
It's not my area of expertise, so I don't know every detail about it, but I know that there are problems in all age ranges or have been concerns across all age ranges. They might be higher for older adults, and there might be lots of reasons for that, but it's not really my expertise, so I don't want to push too hard on that.
Last question.
I'm not quite sure exactly how to put this, but I've heard that there's suggestion that, for example, that we should turn off our televisions, turn off our computers 2 hours before going to sleep because the emissions from the monitors affect certain areas of the brain. And so now we're being told that the way to help the brain is to add more of those emissions. So I hope you understand what I'm asking.
Well, I didn't necessarily say to do it in bed before you go to sleep. I mean, and also, I mean, it's a good point in general. You know, moderation is critical. If these are tools, they're things that you use, 20 minutes to train a system. That it's different than how we think about games with something like a kid will play for 6 hours. That's not at all what I'm talking about. This is like a sort of digital pill. You take it in an intense way, and then you wait a day. So, I know that's not exactly what you're asking, but I think that digital technology has to be used carefully, and we're going to figure out what the side effects are of this, because everything has some potential negative effect, even something that seems more benign. In terms of monitors and sleep, there's definitely evidence coming out that the way our circadian rhythm responds to light might be affected by the emissions of digital devices if we use them right before bedtime. And where that cutoff is it literally like, you're looking at it and then you try to go to sleep and you can't, or is it an hour? I don't think we know yet, but sleep is not to be underestimated, right? That should probably be up there too. Maybe I'll make a longer ending to this talk. But we know that sleep is a powerful influence on our health and our brain function. Cognition, memory, incredibly important to get good sleep. We know that people are sleeping less, and there's lots of reasons for that. Some of that could be our new digital world, but it is important and shouldn't be underestimated, the impact of that on your brains. Okay.
Dr. Gazzaley, thank you very much for the presentation today. Greatly appreciated.